First, we have a weight on a spring that's going to bounce up and down, and it says write a harmonic function for this. And they tell us that it's pulled down 4, and if positive is up, that's -4 for the initial displacement, down 4. And since we're starting not on this at the center, but pulling it down, we're going to be doing a cosine function. If it started at the center and then went up and then down and up and down and up, that would be sine. If it went from the start of the center and went down and up, that would be sine upside down. If we pushed it up and then dropped it, it would go down 4 and up 4 and down 4 and up 4 from the center, and that would be a positive cosine. But this is pulled down 4. They didn't say it, but that's what they mean. And then you do the normal period, which is 2 pi, divided by what the period is, pi over 2, and that's what you put in front of the t. So now we have to figure out what that is. Well, we can multiply by 2 over pi, and that on the numerator and the denominator. And this would cancel this, and we'd get 4 pi over pi, the pi's cancel, and we get 4t. And that would be the equation. All right, 13. Got a periodic motion that's periodic, and so the displacement is figured out by 5 times the sine of this. What is this? This is periodic harmonic motion, or oscillating motion. The maximum displacement is the amplitude, 5 units. Time for the oscillation. So the normal period is 2 pi divided by 3. And so we can figure out what that is in decimal, but it would be that many, whatever time is in, seconds probably. 2 pi over 3 seconds. And the frequency is simply the reciprocal of the period. So that'd be 3 divided by 2 pi hertz. Hertz is how many cycles per 1 second. The reciprocal of that. And that's it. 22 says graph this for 0 to 2 pi. So if I go pi, 2 pi, but this has a period of 2 pi divided by pi, which is 2, divided by 2, which is pi. So it's going to do a full wave by pi. So I want that in 4 pieces. In the second period in 4 pieces. So that's pi. This is pi over 2, pi over 4, 3 pi over 4, 3 pi over 2, 5 pi over 4, 7 pi over 4, and 2 pi. And I'll put 1 here, and -1 here. And now at time 0, this is time, at time 0, put 0 in here, minus t to the minus 0 over 2 pi is 0, e to the 0 is 1, so the amplitude would be at 1. So I'm just going to kind of mark it with little x's here. And then at pi over 2, which is 1 point, well, we'll just put it into the calculator. So we want to know the amplitude. This determines the amplitude, and it's changing. Let's put in pi over 4. Actually, let's do this. We want to know what e to the minus x, whatever I put in for the x, over divided by parenthesis 2 pi, close parenthesis. Enter. So I have minus x divided by that. Now I can go to second table set and start at 0 and step by pi divided by 4. And then I can go to second table, and it says at pi over 4, actually I only need pi over 2, which is 1.57. It's at 0.77. There's 0.5, so 0.77 is a little over 3/4 above and below. And then at pi, it's 0.6, which is about there. And then at 3 pi over 2, 1/4, 2, 3, 4, 5, 6 is 4.7. 4.7, almost 0.5. And then at 2 pi, which is 6.28, it's at 0.36, 0.37. So we've got a cosine curve that's going to weigh between this line that's decreasing and this line that's decreasing. The decreasing, that's the amplitude that's damped. So cosine starts at 0 times 0 will be at the top. After a quarter of the period, it's down on 0, then it's at minus, and then it's at 0, then at the top, and at 0, at the bottom, at 0, and back at the top. Okay? And so on. And finally, 51. We got a loudspeaker, and we're supposed to write the function for its displacement. Well, the amplitude, they said it's going by 0.8 millimeters off a center, 0.80 millimeters. Cosine, and for the W, we always do 2 pi divided by the period. Well, they didn't give us the period. They told us the frequency, which is 1 over the period. So the period is 1 over the frequency. So down here, 2 pi divided by the period, which is 1 over the frequency. So we would multiply numerator and denominator by 520. That would cancel that, and we'd get the number that we have to put in front times t will be 2 pi times 520, which is 1040 pi, where time is in seconds and the displacement's in millimeters.